Hi. When we start looking at the business of using the rising tide to pump water, one easy way to look at it is if we have a float on top of the water and we have a platform or a float anchored to the bottom with a large cylinder or baffle underneath our platform anchored to our float with cables, and we can have a water line that comes out. And so as the tide rises, the float rises, compresses the baffle, pushes the water out and up through the hose. The nice thing about this is if this is 20 feet or 200 feet, the volume of water pumped stays the same. And there's real energy gains by pumping it up to a higher elevation, of course. There's some constraints and problems with this. One is constructability and maintenance. Everything is below the water. Also, on the incoming tide is the only time that it pumps. You could have a baffle underneath that the weight would compress on the outgoing tide and also pump water. But to get any real volume of water, the cylinder would have to be really large, and constructability is an issue with a large cylinder, especially when you're pumping to high elevations, because those elevated pressures require pretty complex construction, which really drives your cost up. So our embodiment, our prototype that we're looking at, uses smaller water pumps, conventional water pumps, like a double acting pump. So it draws water in behind the piston and forces water out in front of the piston. Pressure is applied to the lever and it pumps water. So when you apply this to our system, let me move this up a little bit. And our first prototype's on a dock, and so everything's out of the water. And let me just move it up a little bit. Wonder if I can. Okay, it's on a dock. Everything's out of the water, so it's easy to work on. But there's a cable, a drive cable, that's anchored to the top of the piling. It comes down around the drum, and around this way, makes several wraps to increase friction on the drum, and it comes down and is anchored on the bottom. That way, as the dock rises, this cable wraps around these drums and it rotates these drums, and by doing the figure 8, it rotates them in opposite directions. This drum would rotate this way, this drum would rotate that way. There's arms on the drum with the pump attached to the arms. And so as those rotate, the pump is extended out and in. This is held up on a framework to the dock, which is not shown. And also there's an intake line going down to the water. And also our exit line comes down across the bottom and then back up a hill in this prototype. And so the pump has check valves, so it only pushes one way. And this is what we're going to see in this animation. Let me go ahead and run it for you. Erase this stuff. There we go. Okay, so you can see the tide going down now, and it's rotating, and the pump, you can see the piston inside the pump back and forth. And it's right down behind the plaything. Here comes the tide again. And so that's the basic principle and basic operation. There would be more than one cylinder. Let me advance it just a little bit. There'd be more than one cylinder. You could have multiple cylinders. In our prototype, we have 2 cylinders, one off each side.